Section 5.3, transforming parabolas. In the previous section, we looked at quadratic functions in the form of f of x equals ax squared plus bx plus c, where I have a quadratic term, a linear term, and a constant. Here, we want to take a look at the vertex form of a quadratic function. The vertex form is f of x equals a times the quantity of x minus h squared plus k, where h, k, the ordered pair, are the coordinates of the vertex of the function. In following sections, we will be able to create this vertex form of a quadratic function from the regular standard form of a quadratic function by completing the square. But here, we're just going to use this form and use the vertex, and with that information, we'll apply different operations to this definition. The family of quadratic functions. We know that a quadratic function is a parabola that is either going to open up or down. The parent function is y equals x squared, where the vertex is at 0, 0, and opens upwards. We know that we can do a reflection over the x-axis if our a is negative. We know that we have a stretch if a is greater than 1, or a shrink if a is between 0 and 1, which is a fraction. And that stretch or shrink is a reflection in the x-axis when a negative a equals x squared. The vertex form, we have the graph and vertex of y equals x squared, and it shifts h units horizontally and k units vertically. For h greater than 0, the graph shifts right. For h less than 0, the graph shifts left. For k greater than 0, the graph shifts up. For k less than 0, the graph shifts down. The vertex is hk, and the axis of symmetry is the line x equals h. When graphing quadratic functions in vertex form, we want to keep this in mind, whether I'm moving the vertex from 0, 0 to the left or right, and also how many units up and down. But in general, we want to use this procedure to graph a quadratic function using the vertex form. 1, find and graph the axis of symmetry. 2, find and graph the vertex. 3, find and graph the y-intercept and its reflection. 4, find and graph another point and its reflection. 5, sketch the graph. Here, we have a function that we want to graph. It is f of x equals the quantity of x minus 3 squared minus 2. The vertex form of a quadratic function is given here, f of x equals a times the quantity of x minus h squared plus k. If this is our general form, and this minus remains inside my function, then that tells me that h is positive. If h is positive, then the function shifts to the right. Here, since my minus sign is here, my h is positive, so this moves the function 3 units to the right. If this was a negative h, that would make this a positive sign inside my quantity. The k tells me the vertical shift, whether it goes up or down. This is a minus 2, so my function is going to move down 2 units. But if we follow the procedure from the previous page, we can state that my axis of symmetry is equal to xh. And here, my value is x equals h is 3. So I can graph my axis of symmetry at the vertical line 3. My vertex is hk. Here, h is a positive 3, k is a negative 2. So from my parent function of 0, 0, it moves 3 units to the right and down 2, represented in our equation, 3, negative 2. My y-intercept is generated by letting x be 0. When I let x be 0, I'm going to get a negative 3 squared, which is 9, minus 2, which is 7. So my y-intercept is 0, 1, 2, 3, 4, 5, 6, 7. And then I map that over the axis of symmetry by 3 units, because that's how far my y-intercept is away from the axis of symmetry. So I'm going to map 3 units to the right for its reflection. Then I'm going to choose one more point. I'm going to choose 1, When I substitute in 1, 1 minus 3 is a negative 2 squared, which is 4, minus 2, which is 2. I'm going to graph 1, 2, and its reflected point over the axis of symmetry, and then I'm going to sketch my parabola. And since my A is positive, I know that my parabola opens up, and therefore my vertex is a minimum. On the next graph, they want us to do the same thing, find the symmetry, find and determine the vertex and the maximum or minimum. Here is the function f of x equals a negative 2 times the quantity of x plus 4 plus 3. Here, since my A is negative, I know that my parabola will open downward. Here my h, if it is positive, I have my function that will have a minus sign inside my quantity. Since this is a positive inside my function they want me to graph, I know that h is negative. So therefore, when I find my axis of symmetry, I know that x equals h, and here h must be a minus 4. So I know if my parent function initiated the vertex at 0, 0, it needs to move left 4 units. My vertex also is determined by the ordered pair hk. So I know h is a negative. K represents my vertical shift up or down. Here it's a positive 3, so it goes up 3 units. So I'll graph my axis of symmetry at a negative 4. Then graph my vertex at a negative 4, 3. Then find my y-intercept, letting x be 0. And when I do that, 0 plus 4 is 4, squared is 16. 16 times a negative 2 is a negative 32. A negative 32 plus 3 is a negative 29. I know that I won't be able to fit that on my graph, therefore it will be way below what I can show on my graph. So what I'll do is I'll pick another point inside that. So I'm going to pick here 1, 2, 3, a negative 3. A negative 3 plus 4 is 1. 1 squared is 1 times a negative 2 is a negative 2 plus 3 is 1. So when I graph that point, a negative 3, 1, and I graph its reflected point over the x-axis. I'm going to graph one more just to verify what my parabola looks like. I'm going to graph a negative 2. A negative 2 plus 4 is 2. 2 squared is 4. 4 times a negative 2 is a negative 8, plus 3 is a negative 5. A negative 2, negative 5, 1, 2, 3, 4, 5, and its reflected point over the axis of symmetry. Then I can sketch my parabola. Here, I have an axis of symmetry at x equals a negative 4. I have my vertex, and I know since it opens downward, my vertex is a maximum. In this example, we're asked to graph the function 1/3 times the quantity of x minus 1 squared minus 2. We're going to follow the same procedures as we have on the previous slides. We're going to determine the axis of symmetry and determine the vertex, maximum and minimum, and also the y-intercept. Here, our axis of symmetry, we already know is x equals h. Here, h is 1. And we know it's 1 because the general function has a minus sign in it. Our function has a minus sign in it. Therefore, h must be positive, or that sign would have changed and made it a negative, which would have been a plus sign. So I have a vertical line at x equals 1. And that is my axis of symmetry. My vertex, I know, is hk, and here h is a 1, k is a negative 2. So if my parent function initiated at the vertex of 0, 0, we know it would shift to the right 1 and down 2. And that's exactly what is shown in our vertex, 1, negative 2. Now I need to determine my y-intercept. We do that by letting x equal 0. When x is 0, I substitute in 0 minus 1 is a negative 1 squared, which is 1. 1 times 1/3 is going to give me 1 2/3, and that's going to be a negative 1 2/3, and that's going to give me 5/3, written as an improper fraction. Now, I can graph that, and it's mapping over the axis of symmetry, 0 and a negative 5/3, which is a negative 1 2/3. And I map that over the axis of symmetry. It's 1 unit to the left, so I'm going to put it 1 unit to the right. And notice that these 2 points are above the vertex, and I know that should be true because my A is positive, and therefore my parabola is going to open up, which tells me my vertex is going to be a minimum. Now, to get a better sketch of my parabola, I need to find another x value ordered pair. So I can generate that by choosing x to be a negative 1, but of course that's your choice. I chose a negative 1. I substitute in. A negative 1 minus 1 is a negative 2 squared is 4. 4 times 1/3 is 4/3. Minus 2, but if I find a common denominator, that's 2 over 1, multiply the top and bottom by 3, I get 6/3. And 4/3 minus 6/3 is a negative 2/3. I want to graph that and its reflected image over the axis of symmetry. So a negative 1 and a negative 2/3. And then I reflect. It's 2 units to the left of the axis of symmetry. I'm going to map it 2 units to the right. Then I sketch my parabola. Then I verify that I've solved all the problems being asked. Identify the axis of symmetry, x equals 1. The vertex, which is 1, negative 2. It is a minimum, and I also found the y-intercept. Our next example, we want to graph the function a negative 1 times the quantity of x plus 3 squared. Again, we want to determine the axis of symmetry. We know the axis is x equals h, so x equals, here it would be a negative 3. I know that because my general function is a negative inside the quantity, I have a positive. So h must be a negative 3, because a negative times a negative would give me a plus 3. Therefore, I have a vertical line at x equals a negative 3. Let's determine the vertex. We know that it is h, comma, k. H, we already determined, is a negative 3. K is outside my quantity. Here, I don't have a k, therefore it must be a 0. So my vertex is a negative 3, 0. And if I was just moving my parent function, which would initiate at the vertex at 0, 0, I would just move it 3 units to the left. My y-intercept is found by letting x be 0, so I substitute 0 in for x. When I do that, 0 plus 3 is 3 squared is 9, but that makes it a negative 9. I'll graph my y-intercept, and I'll also reflect that over the axis of symmetry. It's 3 units to the right, so I'll make it 3 units to the left. I also know that should be the case that these 2 points are below my vertex, because my A is negative, therefore my parabola should open down, making my vertex a maximum. Let's generate one more point to help sketch my parabola. I'm going to choose a negative 1. Again, that's your choice. This seems to be the easiest. A negative 1. A negative 1 plus 3 is 2. 2 squared is 4. 4 times a negative 1 is a negative 4. I'm going to plot that point, a negative 1, negative 4, and also map that over my axis of symmetry. It's 2 units to the right. I'll map it 2 units to the left, and I'll sketch my parabola. Let's check to make sure I've answered all the questions. Identify the axis of symmetry. It's at x equals a negative 3. My vertex is a negative 3, 0. It's a maximum. I also identified my y-intercept. In this example, we're asked to write the equation for the parabola below. We're given two ordered pairs. The first one is the vertex. We know the vertex is labeled h, k. Here we have another ordered pair. It just happens to be the y-intercept. It wouldn't matter what other ordered pair. But we do know that the x and y coordinates are given, so this is our x and y coordinates. If we go back up to our general function, we're given 1, 2, 3, 4, 5 different variables, or unknowns. We know that f of x is labeled y. All we need to do is substitute our 4 known terms given in our two ordered pairs into the general formula and solve for the fifth term. Then we would know our equation for the parabola. So let's substitute in. F of x is y, so I'm going to plug in a negative 3. I don't have an a given, so it just remains a. X is given by 0. H is a negative 1, so a negative is going to be plus 1 squared, plus k, which is a negative 4. Now, all I need to do is simplify the right side of my equation and then solve for a. So I bring down a negative 3. A times 0 plus 1 is 1. 1 squared is 1, so 1 times a is just a, minus 4. Add 4 to both sides, and I get a equal to 1. Now I use my general formula. I have f of x equal to a. In place of a, I put 1. X, h is a negative 1, so that's going to be plus 1. K is a negative 4, so that's just going to be minus 4. So the function that represents this graph is f of x equals x plus 1 squared minus 4. Again, in this problem, they want us to find the equation of the given parabola. I'm given the vertex, which we know is h, k, and I'm given an ordered pair, which we know is x and y. We can use the general formula, which is f of x equals a times the quantity of x minus h squared plus k. Let's substitute in the known values. We know that f of x is y. Y is a negative 2. A is unknown. X we know is 2. Minus h. H is given to be 1. Squared plus k we know is 0. Let's just simplify and solve for a. That gives me a negative 2 equals a. 2 minus 1 is 1. 1 squared is 1. 1 times a, just a. And I don't even need the plus 0. So I'm given that a is a negative 2. Let's substitute back into our general function. F of x equals a, which is a negative 2. And I'm glad it's negative because our parabola opens down, so it needed to be negative. Times the quantity of x minus h, which is 1, squared, and plus k, but k is 0. So my function for the graph is f of x equals a negative 2 times the quantity of x minus 1 squared. On this example, we're asked to write the function in vertex form. We're given standard form. We know that standard form is y equals a x squared plus b x plus c. We know we want to get this form to be f of x equals a times x minus h, quantity squared, plus k. We already know the a. We need to determine our h and k. If we recall from a previous section, we could find the vertex if we're given standard form by solving the equation x equals a negative b over 2a. So we can just substitute in our b and a and get our x value. To do that, we get x equals a negative b. Here b is 12, so that's a negative 12, over 2a is a negative 3, so that's 2 times a negative 3. That gives me, when I simplify, negative 12 over negative 6, which is 2. Now, I can solve for y by plugging in 2 into my standard form. So y equals a negative 3 times 2 squared plus 12 times 2 plus 5. So y equals a negative 3, 2 squared is 4, gives me a negative 12, plus 12 times 2 is 24, plus 5. Therefore, y is equal to negative 12 plus 24 is going to give me 12 plus 5 is 17. If you recall from our previous slides, this generates our vertex if we're given the standard form, which tells me my vertex is 2, 17. But we know our vertex in our vertex form is hk. So now, knowing h, k, and from our standard form, we know a. I can now substitute these three variables into my general function for the vertex form. F of x equals a, which we know is a negative 3. And if I graphed, I know my parabola would open downwards. X minus h, h we know is 2. And we know that k is a positive 17. So this standard form, y equals a negative 3x squared plus 12x plus 5, can be written in vertex form, which is f of x equals a negative 3 times x minus 2 squared plus 17. In the previous example, we were asked to take a quadratic function in standard form and put it into vertex form, like we have here. In this problem, we're asked to take the vertex form and put it into standard form. To do that, what we need to do is FOIL this function here that is squared. To do that, I'm going to just rewrite 3x minus 4 twice. In other words, we're going to write it as a product of its factors. Then, what we're going to do is perform the operation that we know is FOIL. FOIL means that we're going to take the first two terms and multiply them together. 3 times 3 is 9. X times x is x squared. O means the outer terms. 3 times a negative 4 is going to be a negative 12. X is going to be brought down. In other words, what we did is take the first term and distribute it through the second set of parentheses. Now I'm going to finish my FOIL. I means the inner two terms, which is a negative 12x. And then L means the last two terms. A negative times a negative is a positive 16. And then what we did is basically just distribute the second term through. So FOIL really means distribute the first term through the second set of parentheses, distribute the second term through the second set of parentheses. Now, all I need to do is to simplify 9x squared, negative 12x minus 12x, they're like terms, minus 24x, plus 16. And this is our quadratic function in standard form. And remember, we have to order them, where they have the quadratic term first, then the linear term, and then the constant. Let's take a look at one more example of making a vertex form of a quadratic function into the standard form of a quadratic function. So we'll bring down the y, bring down the negative 2. Then we're going to FOIL this quantity, x plus 3 squared. So I'm going to write that as a product of its factors. and then bring down to plus 6. And here I'm going to FOIL again, but I need to bring down the negative 2. FOIL, in other words, distribute each term through this set of parentheses. First, x times x is x squared. Outer, x times 3 is 3x. Inner, 3 times x is 3x. And last, 3 times 3 is 9. And bring down the plus 6. And if you notice, I put a set of parentheses around my FOILed quantity. And I had to do that because negative 2 is going to multiply that quantity. Now, I can either multiply negative 2 now or simplify inside first. I'm going to choose to simplify inside. That gives me x squared plus 6x plus 9 plus 6. Now I'm going to distribute the negative 2 through the set of parentheses. Just these terms. The 6 is not included in here, so it doesn't count. Negative 2 times x squared is a negative 2x squared. Negative 2 times 6 is a negative 12x. Negative 2 times 9 is a negative 18 plus 6. Then combine like terms. Negative 2x squared minus 12x. Negative 18 plus 6 is going to give me a negative 12. And remember, we have to put it in descending order. Quadratic term first, linear term second, constant term last. And this is your standard form from this vertex form.